Hey guys, Mr. McKinney here, just finishing up our Unit 6 review series. The last day of Unit 6 was on sigma and Riemann notation, or sigma notation and Riemann sums. Riemann sums will definitely be on the AP exams. Sigma notation will be on probably the multiple choice portion of the AP exam, and it'll show up on one or two questions. So it's not a major piece of the AP exam, but it's almost guaranteed to be on there on one or two questions. It's just a matter of memorizing formulas and then practicing using them. So let's take a look at some examples. Let's talk about sigma notation first. So sigma notation is basically just the idea that you can convert a definite integral, which is talking about area, into an infinite sum. And so if you ever see an infinite sum being referenced, it's probably talking about sigma notation. So it's saying that you can, instead of finding the integral with some rectangle or triangle or trapezoid formula, if we have a weird curve, then what you're going to do is you're going to use rectangles, but you're going to make them infinitely skinny because you're going to have infinitely many of them. So you're going to make them skinnier and skinnier, and you're going to add up their heights. So essentially you're just adding up a bunch of lines. And if you make those infinitely skinny, the limit as the number of them goes to infinity, then adding up all these little rectangles or adding up all these lines will give you the exact same value. So this integral is exactly equal to this limit of an infinite sum. So the main thing is, if you want to use sigma notation, you have to convert into this notation. So use a and b to convert into delta x. So a and b will be numbers, n is just going to stay there. And then x of I is always just going to be a plus k times your answer here. N and k will be in your final answer. So your final answer will have limit as n approaches infinity, and you'll still have k going from 1 to n. Inside your answer, whatever your equation is, you'll plug in a plus, and a will be a number, but you'll still have k times this, and that'll still have n in it. So go back and watch these videos. It's just a matter of using these formulas. The other thing we talked about on this day was Riemann sums. And we talked about left, right, midpoint, and trapezoid Riemann sums. So they're just different ways to approximate the area underneath it. So this is kind of a picture of a rectangular Riemann sum. Most of them are rectangles. There's also the trapezoid method, which basically just averages these two rectangle methods. So what you're going to do is figure out how many intervals they are. If they're equal intervals, then you can just divide the total distance by the number of intervals. If they're unequal, then you're going to have to use the data that they give you. Sometimes it'll be a table of values, and you can go from there. A left Riemann sum will use the height of the point that is on the left of each interval. So on this first interval, I'm going to use this height. On the second interval, I'm going to use this height. On the third interval, I'm going to use this height. On the fourth interval, this height. And on the fifth interval, I'm going to use this height. If I was doing a right Riemann sum, let's do that in red here. So if I was doing a right, I would have all the same intervals, but I would use this point for the first interval, and this point for the second interval, and this point for the third one, this one for the fourth one, and this one for the last interval. So the only difference between left and right is whether you're using the height that's on the left or the height that's on the right. And then you're just adding up rectangles. So each rectangle, the area of a rectangle is just base times height. So for each rectangle, you're doing the base, the width of an interval, times the height. Depending on whether you're using left or right, will tell you which endpoint to do. Then we went through midpoint and trapezoid method. One thing to keep in mind is when you do the midpoint method, you're using the x value at the midpoint, and then you're finding the y value of that. So you find the x value that's the midpoint and then plug it into y. You're not averaging the y values. That's what the trapezoid method does. The trapezoid method, like for this interval right here, would use both of these heights, and it would use a trapezoid formula. So you'd have 1/2 times 1 times whatever these two heights are. So it looks like about 4.2 and about 3.6. Go back and watch the original videos if you want a better explanation. On the AP exam, they will likely ask you if your Riemann sum approximation is going to be an over or an underestimate. So think about whether your function is like concave up or concave down or increasing or decreasing. Draw yourself a function that looks like that, and then think about, okay, depending on whether I'm using a left sum, in this case a left sum would be an underestimate, or if I was doing a right sum would be an overestimate. You can try to memorize this table, but I don't recommend that. I recommend that you practice drawing pictures and then figure out, based on whether I'm drawing the rectangle going to the left or the right, is it an over or underestimate. Trapezoid sums care about concavity. Left and right Riemann sums care about whether you're increasing or decreasing. All right, hope this was helpful. This was just a quick review of Unit 6. You can just go back and watch any of the videos on a specific topic that you want more of a review on. Good luck.